All right, guys, so in this section of 5.1, we talked about a rational function, which is basically a function with which is a function defined by the fraction of two functions, a function on the top and a function on the bottom, or I would say the division of two polynomial, whatever the degree would be. It's directly connected to what we did before in terms of division of polynomial. So we have a polynomial, we have a function f of x, which is the division of two polynomial, p of x divided by q of x. Okay? And so what we're trying to do is again trying to analyze this function and try to study this function. And so in this problem number 1, the question is about what is the domain of a function f of x equal 1 over x. So if I graph my function f of x equal 1 over x, and you should know, it's one of the functions that you should know how to graph very quickly, we're having something like this. So first of all, you can see that there is a vertical asymptote. And this vertical asymptote is right here. This is the vertical asymptote, and it's defined at x equals 0 is the vertical asymptote. When you graph a line, when you graph x equals 0, it's a vertical line. And why do we call that a vertical asymptote? Because x cannot be equal to 0. Therefore, when I look at my domain and my range, and you should know that the domain is defined on the horizontal when the range is defined on the vertical, I can see also clearly that there is an horizontal asymptote because we can define a plus 0, and this plus, I'm going to write that in another color, this plus 0 right here define a y equals 0, an horizontal asymptote. So when I define my domain, well, my domain is going to be defined between negative infinity and 0. I'm not going to take the 0. And then I continue to move in that direction. And so I end up to have union 0 plus infinity. Regarding the range, I'm going to move in that direction. And I'm getting a negative infinity 0. Union 0 plus infinity. I can see clearly, first of all, I should remember why do I have a parenthesis next to the 0? It's because 0 cannot be part of the solution. The graph will show that it tends to be very close to 0, but it cannot be equal to 0 because we are getting closer to an asymptote. All right, problem number 5. On this problem number 5, what do we have? What is the equation of the vertical asymptote of the graph y equal 1 over x minus 3 plus 2? And we need to also to define the horizontal asymptote. Well, to find the vertical asymptote, what you need to do is to study the denominator and say that the denominator cannot be equal to 0. Therefore, the denominator cannot be equal to 3. And so at x equals 3, you will have a vertical asymptote. For the horizontal asymptote, very easy. You look at plus, and you can clearly define right here that y equal 2 will be the horizontal asymptote. So now I can move on to the problem number 8. On the problem number 8, what do we have? Is f of x equal 1 over x? See, if f of x equal 1 over x, and so the question is f of x equal 1 over x is even or odd? Okay, and what symmetry does it graph exhibit? All right, so you should remember that f of x equal 1 over x is an odd function. F of x equal 1 over x is an odd function. And if you look at, I'm going to go back right here, if you look at what is the symmetry, you are going to look at the origin. Why? Because and my graph is not perfectly done right here. I should do something but maybe more like that. Okay. Here we go, like that would be better. Well, right here, you can see that through these 2 points right there are symmetric. A and A1 are symmetric through the origin O right here. Okay, so now I need to do the problem number 17. All right, so what do we have on this problem number 17? On this problem number 17, oops, I'm going to change the color again. And I'm going to try to see if I can move this. There we go, that will be much better for you. Problem number 17. So on the problem number 17, they are asking us, explain how the graph f can be obtained from the graph y equal 1 over x or y equal 1 over x squared. And we have f of x equal 2 divided by x. So we have the graph f of x equal 2 divided by x, which is 2 times 1 over x. So if I call g of x equal y equal 1 over x, I can clearly see that I have f of x equal 2 times g of x. So what do I have right here? Do I have a stretch? Do I have a shrink? Do I have a shift? What you should recognize right here is something looking like f of x equals cg of x with c greater than 1. And you should remember this, okay? That when you have a function f of x equals cg of x and c is greater than 1, we have what we call a vertical stretch, okay? Meaning that the value of y are going to be stretched, And so when I am graphing my function right here, that would be f of x. This blue function will be f of x, will be g of x, actually. I'm going to just be correct. It will be g of x equal 1 over x. Well, my function f of x being equal to 2 times g of x, every single value of y are going to be stretched. So this value right here is going to be here. Oops, I'm going to change. This value right here is going to be here. This value right there is going to be here. This value right here is going to be here. This value right here is going to be here for the same value of x, by the way. So I'm going to have something like that. And obviously by symmetry, something like this. Oops, and I should not. There we go. All right. So this is how you're able to graph the function f of x for the problem number 17. So on the number 23, we have g of x equal 1 over x minus 1. This g of x, it's like if you had y, and let's call h of x this time equal 1 over x. It's like if you had g of h of x minus 1. And so that should remind you that we have an horizontal shift to the right or to the left. What do you think? Well, because you have a minus, it's going to be to the right. So basically, if I had to graph just g of x right now from my function for my function h of x, and that is h of x equal 1 over x, well, 1 over x minus 1 is going to be, everything is going to move 1 to the right. So I am going to have, so if my 0 was right here, now my 0 is kind of, it's like if I was almost like that now. Okay? And so I'm going to have something looking more like this. And that would be g of x equal 1 over x minus 1. And then, when I look at my function f of x, which is with a plus 1, that tells me that there is a shift of 1 unit, meaning that my horizontal asymptote, which was still for my g of x, my horizontal asymptote is at y equals 0 because I got plus 0 right here. Now my horizontal asymptote is at plus 1, right? This is going to be an horizontal asymptote for my function f of x. Therefore, I have my horizontal asymptote, which is going to be right here, and the red one is going to be the function f of x, which is 1 over x minus 1 plus 1. All right, now next. All right, so in this problem number 29, we have the function f of x equal 1 over x minus 3 squared. If I represent g of x right here as 1 over x squared, I can see clearly that x equals 0 is a vertical asymptote because my denominator right here is telling me that x cannot be equal to 0. And so when I try to look at the function g of x equal g of x minus 3, which is the function f of x defined in your problem, what do we have is at least we can look at the denominator and say that x minus 3 cannot be equal to 0, so x equals 3. So x cannot be equal to 3. And if x cannot be equal to 3, that means x equals 3 is a vertical asymptote. So if I had to represent on my function just g of x, that would be x equals 0, the vertical asymptote for the function g of x. And if I want to graph my function f of x, I will have to first of all go to x equals 3, 1, 2, 3. That would be x equals 3, the vertical asymptote for the function f of x. Do I still have an horizontal asymptote at y equals 0? Yes, because when I look at my function 1 over x squared, I can see clearly that there is a plus 0 right here, meaning that we are dealing a y equals 0, a vertical and horizontal asymptote. And when I look at my function f of x equal 1 over x minus 3 squared, I got exactly the same thing, plus 0. And that means that y equals 0 is an horizontal asymptote. So for both of them, I got the same y equals 0 vertical asymptote. And so now I can very easily graph my function f of x equal 1 over x minus 3 squared. All right, guys, so in this problem number 39, you have the function f of x equal x minus 1 divided by x minus 2, and they are asking you to rewrite the expression and sketch the graph by hand. So in order to do that, what I want to do is do the division of x minus 1 divided by x minus 2. I could do the long division. I decided to do the synthetic division. I take what I see, so I take negative 2. Therefore, if I take what I see, when I will do my synthetic division, I will subtract. I take 1 and negative 1 as the coefficient. I have a decreasing exponent, so we're good to go. Negative 2 by 1 equals negative 2. And negative 1 minus by minus give me a plus. So that transforms into a plus when I multiply this negative by this negative. And so 2 minus 1 give you plus 1. Therefore, my function f of x is equal to 1 plus 1 over x minus 2. So I can see clearly that there is my function f of x is equal to a function g of x equal g of x minus 2 plus 1. And g of x minus 2 is a shift of 2 units to the right from the function f of h of x equal 1 over x. And this plus 1 is correspond to the shift of 1 unit up of the function g of x minus 2 that we graphed previously. All right, guys, I don't have enough time to correct the last exam, but I think last problem, but I think you will be fine. And hopefully this helps explain everything for you. All right, bye-bye.